Just convert 765 degrees into less than 90 degree by using the relation 2 into 360 plus 45 degrees. Okay. Suppose if you want to find the value of sine of 15 degrees, cos 15, tan 15 or sine 75, cos 75, tan 75. So for that we are going to use the concept of a sum and difference of two angles. Therefore, the coordinates of P4 are x is equal to 1 and y coordinate is 0. 1, 0 is the coordinate of the point P4. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the problems based on trigonometrical functions. So, conversion of one trigonometric function into another function and also finding the trigonometrical ratios for angles greater than 90 degrees. Now, in this session also, I am going to take few more problems based on exercise number 3.2 and I will take very important derivation today. That's very important for the point of examination. Let me start with the problems based on exercise 3.2. Now, in exercise 3.2, here we have few problems related to the conversion of trigonometrical function from more than 90 degrees, finding the value of trigonometrical ratios if it is greater than 90 degrees. Now, let us come to the first value. First one, find the trigonometrical function of sine of 765. Now, convert this 765 into multiples of 180 or 360. 765 can be written as 2 into 360 plus 45 degrees. What is 2 into 360? This is 720 plus 45. This is equal to 765 degree. So, therefore, I can write this as sine of 765 can be written as 2 into 360 plus 45 degree. Now, the cycle of sine repeats for a very value of 2 pi. So, for sine of 2 pi plus theta, you will get the same trigonometrical function. So, here sine of 2 into 360 plus theta is equal to sine theta. Instead of theta, it is 45 degrees. Since you know the value of sine 45 is equal to 1 by root 2. So, the simplified answer for this is 1 by root 2. Sine of 765 degrees is equal to 1 by root 2. Just convert 765 degrees into less than 90 degree by using the relation 2 into 360 plus 45 degrees. Okay. Otherwise, you can also use 4 into 180 plus 45 as you wish. Okay. Now, let us come to the next problem. Find the value of the trigonometric function cosecant of minus 1410 degrees. Now, here what is the problem given? Cosecant of minus 1410 degree. Since cosecant of minus theta is equal to minus cosecant theta, so this can be written as, you can take minus out, minus cosecant of 1410 degrees. Now, let us find out the value of 4 into 360. What is 4 into 360? 1440 degrees. Now, what is required to find is 1410 degrees. So, subtract 1410. What you will get? 30 degrees. So, therefore, this can be written as minus as it is. Cosecant of 1410 degree can be written as 4 into 360 minus 30 degrees. So, what is this equal to? 4 into 360 is 1440 degrees minus 30 degree will give a value of 1410 degree. So, this is equal to minus. Since find out the value of cosecant of 4 times 360 minus theta. Since the value of cosecant of 4 into 360 minus theta is equal to minus cosecant theta. So, this is equal to minus of cosecant 30 degree, minus into minus plus cosecant 30. What is cosecant 30? Cosecant 30 is equal to 2. That's it. See here. So, first point, cosecant of minus 1410 degree can be written as minus out minus cosecant 1410. 1410 degree can be written as 4 into 360 minus 30. 4 into 360 is 1440 minus 30 will give 1410 degrees. So, since cosecant of 4 times 360 minus theta is minus cosecant theta, so this is minus cosecant theta, minus into minus plus cosecant of 30 is equal to 2. So, the simplified answer for this is 2. So, cosecant of minus 1410 degrees is equal to 2. That's it. Hope you followed. Now, let us come to the next problem. Find the find the value of the trigonometrical function tan of 19 pi by 3. So, if you want, you can convert 19 pi by 3 into degrees and simplify. Otherwise, right away you can find out the value tan of 19 pi by 3. So, this 19 pi by 3 can be written as 6 pi plus pi by 3. 19 pi by 3 can also be written as 6 pi plus pi by 3. If you want, you can take LCM. 3 is the LCM. 6 3s are 18 pi plus pi. This is equal to 19 pi by 3. So, therefore, this can be written as tan of 19 pi by 3 can be written as 6 times pi plus pi by 3. So, again this is of the form tan of 6 into 180 plus theta. So, this is equal to tan theta itself, tan pi by 3. So, tan of 6 pi plus pi by 3, tan 6 into 180 plus theta is equal to same tan theta, we will get tan theta, that is tan pi by 3. Pi by 3 is nothing but 60 degree. Tan 60 is equal to root 3. The simplified answer for this is root 3. That's it. Okay. Listen to me. Tan of 19 pi by 3 can be written as 6 pi plus pi by 3. So, if you simplify 6 3s are 18 plus 1 is 19 pi by 3. Since tan of 180 into 6 times 180 plus theta is tan theta. So, tan pi by 3 is root 3. That's it. Okay. Now, let us come to the next problem. Sine of minus 11 pi by 3. Now, sine of minus 11 pi by 3. Since first convert this, since we know that sine of minus theta is equal to minus sine theta, this can be written as minus of sine 11 pi by 3. Now, convert this 11 pi by 3 into less than 90 degree. That's it. So, this 11 pi by 3 can be written as 4 pi minus pi by 3. See here, what is the LCM? 3 is LCM, 4 3s are 12 pi minus pi. This is equal to 11 pi by 3. So, therefore, this can be written as minus of sine 11 pi by 3 can be written as 4 pi minus pi by 3. So, see 4 is a 12 minus 1 pi is 11 pi by 3 you will get. Now, this negative sign as it is minus, since sine of 4 pi minus pi by 3, 4 pi minus pi by 3 is equal to what we will get minus sine pi by 3. That is sine of 4 times pi minus pi by 3 is equal to minus sine pi by 3. This minus and minus is equal to plus sine pi by 3. Sine pi by 3 means this is nothing but sine 60. Sine 60 is equal to root 3 by 2. The simplified answer is root 3 by 2. That's it. So, here first point, sine of minus 11 pi by 3 can be written as minus of sine 11 pi by 3. So, 11 pi by 3 can be splitted as 4 pi minus pi by 3. 4 pi minus pi means 4 into 3 is 12 pi minus 1 pi is 11 pi by 3. Since this is of the form sine of 4 into 180 minus theta is equal to minus sine theta, minus of minus sine pi by 3 is plus sine pi by 3, sine pi by 3 is equal to root 3 by 2. Now, let us come to the next problem. What is given? Find the trigonometrical function, the value of trigonometric function cot of minus 15 pi by 4. Cot of minus 15 pi by 4. Since you know what is the value of cot of minus theta, cot of minus theta is minus cot theta itself, minus cot 15 pi by 4. Now, convert this 15 pi by 4 into less than 90 degree. Now, convert this. This 15 pi by 4 can be written as 4 pi minus pi by 4. See here, take LCM, 4 is LCM, 4 4s are 16 pi minus 5 is 15 pi by 4 you will get. So, this can be written as minus cot of 15 pi can be written as 4 pi minus pi by 4. So now just I will keep this negative sign as it is, minus, since cot of 4 into pi, 4 into 180 minus theta is equal to minus cot theta itself, minus cot pi by 4. So this becomes minus into minus plus cot 45 degrees. What is cot 45? Cot 45 is equal to 1. That's it. The simplified answer is plus 1 is the required answer. That's it. Okay. Hope you followed this. So these are few problems based on conversion of trigonometrical ratios if it is greater than 90 degrees. We are using the concept of allied angles here. Now let us come to the very important concept that is called trigonometric functions of sum and difference of two angles. Suppose if you want to find the value of sine of 15 degrees, cos 15, tan 15, or sine 75, cos 75, tan 75. So for that we are going to use the concept of sum and difference of two angles. So the trigonometrical functions of sum as well as the difference of two angles. So in this we are going to derive very important concept and very important formula indeed. In this section we shall derive the expression for trigonometric functions of sum and difference of two numbers or two angles, and related expression. The basic results in this connection are called as trigonometrical identities, and we have seen, we might have been studied in allied angles, the value of sine of minus x, sine of minus x is equal to minus sine x, and cos of minus x is equal to plus cos x. Sine of minus theta is equal to minus sine theta, and cos of minus theta is equal to plus cos theta. That is, we have studied so far. Now for example, let us consider for example sine of minus 30 degree can be written as minus of sine 30, and this is equal to minus 1 by 2. Whereas if you consider cos of minus 30, this can be written as cos 30. This is equal to minus becomes plus cos 30 degrees. Okay. Now here in this session we are going to express the sum and the difference of two numbers or two angles. So for that we are going to use sine and cos, sine of a plus b, cos of a plus b, or sine of a minus b, cos of a minus b. Similarly tan of a plus b and tan of a minus b. Okay. Now let us come to the first derivation. Let me consider the sum of two angles like x and y. If x and y are the two angles, then x plus y, x minus y are the sum and the difference of the two angles. Now let me discuss the very important derivation. So that is to derive, to prove that cos of x plus y is equal to cos x cos y minus sin x sin y. This is very important derivation. You may expect this for 6 marks in part E. This is part E question for 6 marks. So what is to prove? To prove that cos x plus y is equal to cos x cos y minus of sin x sin y. Now to derive this, now let us consider a unit circle with O center and the unit radius. Now mark the points P1, P2, P3 and P4 as a coordinates. So now let us consider the unit circle with O as center. Here this is the unit circle with the, now O is the center of the circle. Mark the points. What are the points here? The coordinates are, now since this is 1 centimeter, 1 unit, therefore the coordinates of P4 is equal to 1, 0, and so this makes an angle. If x is the angle between P1 and P4, so that is the coordinates of P1 are cos x and sin x. Similarly, the coordinates of P3 are cos of minus y and sin of minus y, and the coordinates of P2 is equal to cos of x plus y into sin of x plus y. Now I will explain why. So here let x be the angle, let x be the angle for P4 O P1 and y be the angle for P1 O P2. This is the angle between P4 and P1 is x, and y is the angle between P1 and P2. Now this minus y is the angle between P3O and P4. Okay. Now see here, let y be the angle between P4 and P3, P4O and P3. Therefore P1, P2, P3 and P4 will have the coordinates as P1 cos x sin x, P2 is equal to cos of x plus y sin of x plus y, and P3 is equal to cos of minus y sin of minus y, and P4 is equal to 1 comma 0. So see here, so let us consider a unit circle with OS center. Therefore the coordinates of P4 are 1 comma 0 since it is a unit circle, and similarly it makes an angle. If x is the angle between P1O and P4, therefore the coordinates of P1 are cos x and sin x. If plus y is the angle between P1O and P2, then the coordinates of P2 are cos of x plus y, this cos of x plus y and sin of x plus y, the sum of these two, entire angle cos of x plus y and sin of x plus y. Similarly, the coordinates of P3 is equal to, here this is P3, the coordinates of P3 are cos of minus y and sin of minus y. So in general, the coordinates of P1 are cos x sin x, P2 is equal to cos of x plus y into sin of x plus y, P3 is equal to cos of minus y into sin of minus y, and P4 is equal to 1 comma 0. These are the coordinates of P1, P2, P3 and P4, the points. Okay, so here P1, coordinates of P1 is equal to cos x comma sin x, and similarly coordinates of P2 is equal to cos of x plus y comma sin of x plus y, and the coordinates of P3, the point 3 is, here we have cos of minus y comma sin of minus y, and the coordinates of P4 are 1 comma 0. These are the coordinates of the points P1, P2, P3, P4 on the circle. Okay, now consider the triangle P1OP and P2OP4. They are congruent. Since these two triangles are congruent, so therefore the distances, therefore the distance from P1 to P3 and the distance from P2 to P4 are equal. See, what are the distance P1 to P3? The distance from P1, the point P1 to P1, the distance from P1 to P3, this distance, the total distance, and the distance from P2 to P4, this distance, P2 to P4, these two distances are same. Since these two triangles are congruent, the triangles, that is P1OP3 and P2OP4, these two triangles are congruent. Therefore, the distances P1, P3 and P2, P4 are equal. Now using distance formula, so using distance formula we can write P1, P3 whole square is equal to, what is the distance formula? Root of x1 minus x2 whole square plus 1 y1 minus y2 whole square, y1 minus y2 whole the square. Or if it's square, the square root gets cancelled. P1, P2 is equal to cos of x minus cos of minus y whole square plus sin of x minus sin of minus y whole square. P1, P3 can be written as cos x into cos of minus theta is plus cos theta, so therefore this can be written as cos y whole square plus sin x into cos sin of minus theta, since cos of minus theta is equal to plus cos theta and sin of minus theta is equal to minus sin theta, so therefore this becomes minus into minus plus sin y whole the square. Simplify this, so a plus b whole square and a minus b whole square, a square cos square plus b square minus 2 cos x into cos y plus sin x sin square x plus sin square y plus 2 sin x into sin y. Now here group these terms, cos square x plus sin square x, cos square x plus sin square x is 1, again cos square y plus sin square y is equal to 1, minus what is remaining is 2 cos x cos y plus 2 sin x sin y. Okay, now this can be written as 1 plus 1 is 2 minus 2 cos x cos y plus 2 times sin x sin y. Okay, see here, so P1 P2 whole square is equal to cos x minus cos of minus y whole square plus sin x minus sin of minus y whole square using distance formula x1 minus x2 whole square plus y1 minus y2 whole square. Since cos of minus theta is equal to plus cos theta, this is cos x minus cos y whole square. Sin of minus theta is minus sin theta, minus into minus becomes plus. So this can be written as sin x plus sin y whole square. So a plus b and a minus b whole square, this is a minus b whole square, a square plus b square minus 2ab, a square plus b square plus 2ab. So here cos square plus sin square is 1, again cos square y plus sin square y is 1, 1 plus 1 is 2 minus 2 cos x cos y plus 2 sin x sin y. Let us represent this as equation number 1. Okay, this is equation number 1. Hope you followed this. Just substitute the values of P1, P2 and using distance formula you can simplify, you will get the first equation P1, P2 whole square is equal to 2 minus 2 cos x cos y plus sin x plus 2 sin x into sin y. Now, similarly, if you go for the second part, what is the second part? P2, P4. Now, P2, P4 whole square can also be written as the coordinates of P2 and P4. So, 1 minus cos of x plus y whole square plus 0 minus sin of x whole square. Now, let us find out the value of P2 and P4. Now, we have what is P2? P2 is equal to cos of x plus y, comma sin of x plus y, and P4, the values of P4 are 1 comma 0. Now this, consider this as x1 y1 x2 y2, the distance P2 P4 can be written as root of x1 minus x2, 1 minus cos of x plus y whole square plus 0 minus sin of x plus y the whole square. So that is 1 minus cos x plus y whole square minus 0. So if we simplify this, a square plus b square minus 2ab, 2 cos of x plus y, again 0 minus of sin is minus, minus square is plus, sin square x plus y. Now this can be written as 1 plus, let us make this to as 1 sin square x plus cos square x plus y, sin square x plus y plus cos square of x plus y can be written as 1. Cos square x plus y, sin square x plus y is 1 minus 2 cos of x plus y. So 1 plus 1 is 2 minus 2 cos x plus y. This is equation number 2. That's it. Okay. Therefore, I can write therefore cos of x plus y is equal to cos x cos y, cos x cos y minus sin x sin y. This is the required answer. That's it. So therefore cos x plus y is equal to cos x cos y minus sin x sin y. That's it. Okay. Hope you follow this, very important for 6 marks. Hence therefore final result we are getting, therefore cos of x plus y, cos x plus y is equal to cos x cos y minus sin of sin x into sin y. This is the final result. Suppose if x is replaced, if y is replaced by, put y is equal to minus y, what happens then? We'll get cos of x minus y is equal to cos x into cos of minus y minus sin of x into sin of minus y. Now then this is as it is, cos of x minus y is equal, you know, since cos of minus theta is plus cos theta, this can be written as cos x cos y minus sin of minus theta, sin of minus y is equal to minus sin y. This minus and minus becomes plus sin x sin y. So hence, what is the second derivation we have? Cos x minus y is equal to cos of x minus y is equal to cos x cos y plus sin x sin y. Suppose in general if x and y are replaced by a and b, instead of x and y if we consider a and b as the angles, then this can be written as x and y are replaced by a and b, then you are going to get cos of a plus b. Cos a plus b is equal to cos a cos b minus sin a sin b. Similarly, for this cos of a minus b, cos a minus b can be written as cos a cos b plus it is sin a sin b. These are the two formulas which we are going to used to solve the problems. If it is less than 90 degrees, like 15 degrees, 75 degrees, 18.5 degrees, like that. Now, so these are very important formulas indeed. Cos x plus y is cos x cos y minus sin x sin y. Cos x minus y is equal to cos x cos y plus sin x sin y. That's it. Hope you followed this. Suppose if you want to find the value of, for example, let us consider the value of cos of pi by 2 plus x. Now, cos of pi by 2 plus, you know, cos 90 plus theta, cos 90 plus theta. Using allied angles you might have been studied, ASTC, cos of 90, cos 90 plus comes under cos 90 plus theta is equal to minus sin theta. So let us check according to the definition what we will get. So this is of the form cos A plus B is equal to cos A cos B minus sin A sin B. Now what is cos 90? Since sin 0 0, sin 90 is 1, sin 91 and cos 90 is equal to 0. If you simplify this, cos 90, this is 0 into cos x minus sin 90 is 1 into sin x. So this is 0 minus sin x, this is equal to minus sin x. So this is equal to minus sin theta or minus sin x. This is without using allied angles, we are going to simplify this using the concept of cos x plus y and cos x minus y formulas. Okay. So that's regarding the derivation. Let us meet with the problems based on this in the next session. That's all for today's session. Let us discuss the problems in the next session. Thank you very much.